In simplest terms, defense in depth is a security architecture design principle that places security controls at multiple layers across the organization's systems. Ideally, it takes a failure of all controls in a series, layer upon layer, to allow an intrusion or attack to get past the defenses successfully. Designing for defense in depth requires understanding the specific threats to the target asset and the anatomy of potential attacks or attack vectors. For example, the specific means by which a particular attack can occur. Defenses may be designed to prevent or deter attacks using an outside-in or inside-out approach. By placing safeguards at 2 or more points along the access path to the asset, failure of one safeguard can be counteracted by the function of another safeguard further along the access path. A firewall protecting an organization's web server may be designed to only allow web browsing, for example, HTTP or HTTPS to the server from the external network. An attacker may circumvent the firewall policy by following an indirect path, for example, accessing a web server via a compromised host or user account with access to the server, by exploiting vulnerabilities in the firewall itself, or by using the allowed ports and protocols for purposes other than those for which they are intended. A defense in-depth strategy might go beyond perimeter defenses, adding safeguards to the web server and hosted web applications. It might do this by disabling unnecessary services such as File Transfer Protocol, FTP, terminal emulation, Telnet, and remote procedure calls, requiring use of a unique identifier and strong authentication method to gain access to services, implementing protections against brute force of passwords or other means. These ensure that the attack vector cannot be compromised by a hacker that bypasses a single control. It is important to note that a true defense in-depth strategy requires that safeguards not share a common mechanism or be dependent on one another for proper operation. This is because failure of a common mechanism causes failure of all safeguards that rely on that mechanism. A failure of a single sign-on solution, for example, would interrupt access to all the systems it supports. Network segmentation is also an effective way to achieve defense in depth for distributed or multi-tiered applications. The use of a demilitarized zone, DMZ, for example, is a common practice in security architecture. With a DMZ, host systems that are accessible through the firewall are physically separated from the internal network by means of secured switches or by using an additional firewall to control traffic between the web server and the internal network. Application DMZs, or semi-trusted networks, are frequently used today to limit access to application servers to those networks or systems that have a legitimate need to connect. We'll look at this in more detail in Chapter 5, Module 4.